I'm here to talk about equipment, and I have good news. I'm very bullish on the industry over the next some number of years. You'll see why in a minute. But the title of my talk, as you can see, Renew, Retire, Replace. So how we can transform our industry, especially the infrastructure, and become healthy again. Okay, let me give you my problem statement. So basically, the market's exploding. That's a real problem, right? Well, not really. It's kind of neat. You can have Bluetooth in your toaster if you want. The expansion we're seeing right now is everywhere. It's 300 millimeter, it's 200 millimeter, it's 14 nanometer, it's 180 nanometers. It's pretty much everything. One of the things that we didn't contemplate in the past was the resurgence of legacy products. So 200 millimeter fabs build pretty much legacy products, anything 90 and above, let's say, in design rule. And there's some data there from SEMI showing the prediction for the number of 200 millimeter fabs over the next number of years. It's actually growing, not shrinking. But the problem is the industry is really structured to respond to the high end. We chase the high end. And we're not really prepared to cope with this mature resurgence. So what the talk is about is how we deal with the fact that the resurgence is upon us. We've basically served the high-end mask market in the past couple of decades with mostly captive manufacturing. The captives have grown tremendously over the last 15, 20 years. And some merchant manufacturing, but mostly captive. And we've served the low end, the standard and mature market, with merchant manufacturing. The suppliers, i.e., writing tool suppliers, inspection, whatever, have chased the high end, and pretty much the strategy, not for every company, but many companies, has been to retire mature tools, or basically not support them. So the problem is the mature tools are what make legacy products. So how do we cope with the legacy resurgence? So what I'm going to do is I'm going to forecast the 2022 IC mask market, and I'm going to segment it by writing tool. I'm going to talk just about writing tools, but I'll show a little bit about other tools, and you can apply it to pretty much any kind of tool in our pantheon of equipment. And I'm going to show how the Mask Writer Toolkit has to change to serve the market as it evolves. Okay, so first let's forecast the market. Let me give you a little bit about my methodology, because I want to predict 2022 mask consumption. Once I know mask consumption, I know what tools I need, right? So the first thing is we already know how we build mask sets. I get a mask set, say 90 nanometer mask set. I know it's built on a variety of different tools, not just a single tool. Every mask is built a different way. I also know the 2017 tape-out volume worldwide. This is everything, not just my stuff, but everybody's. And I know it's segmented by market and technology. There's a lot of work behind getting that data, but I have it. And you can see there the third little bullet, the 2017 mask consumption is really equal to the tape-out volume times the masks per tape-out. Pretty simple, right? Then the next thing is to build a 2022 mass consumption model using market growth predictions from a lot of the different pundits. There are so many different people predicting what's going to happen in different segments of the market, and then make educated guesses, but they're highly educated, about what tape out and mask market growth is going to look like as a result of those growth predictions. And then from that, forecast what the 2022 toolkit for making masks what it needs to look like. So like it says there, I'm not going to show for the entire mask manufacturing toolkit. It's way, way too much work to show that, and I'd need 2 hours. So here we're going to talk about especially eBeams, but I'll talk a little bit about other writers as well. So just to illustrate the methodology, at the top we have the 2017 masks, and we've segmented them by product types. And you can see the different products there. And then for each product type, I've shown for digital CMOS here, we segment by technologies. And I lump the technologies. I don't do each so-called design rule separately. I call it, basically elderly, quarter and up, the teens. 90 and 65 really is the same node anyway. The pitch is the same. 40-28 we lump together, yada, yada, yada. You can see down below. And the number of sets in 2017 is shown for 3 different segments of the market. The very older market, a little under 2,000 sets last year. 40-28, about 1,400 sets. And then 10.7.5 logic, less than 100 sets in 2017. Of course, as you can imagine, some of these are growing pretty dramatically. Then for each set type, and I've shown here for 40/28, what does a typical mask writing tool segmentation look like? And you can see on the right, I've split it up into 5 different kinds of writing tools, from advanced beam to standard and mature laser. And you can see there the number of layers in a typical 40/28 logic set, what it looks like. And by the way, I didn't just make these numbers up. These are averaged over roughly 40 customers. So for each of these different kinds of products, there's a lot of data to back up the segmentation. So that's the methodology, and that gives me what was done in 2017. So just to expand on logic a little bit further, this is what the logic set writing toolkit looks like as a function of the different design rules. So the horizontal axis is the different technology levels, and then the vertical axis is the number of masking layers built by the different types of writing tools, which are shown in the legend at the top. And there are a few things that are interesting here. The first is that basically all sets except very old stuff use multiple writing platforms, okay? The second is that lasers are used at every node, interestingly. And the final thing is that low-end eBeams didn't last very long. They went through about 6 design rules, but that's 3 nodes in my vernacular. So that's kind of interesting. And you can do this for any of the different product types. You're going to get similar kinds of behavior, right? You can also see the number of masking layers goes up as the technology gets tinier. And I know some people will argue that 10.7.5 has more than 75 or 80 layers. Yeah, probably. We've seen things with a lot more, but that's just kind of an average that I put in. Okay, so then how do you forecast tape-out activity in 2022 versus 2017? So what I showed you before was mask set segmentation by writing tool. This is actually my prediction for tape-out activity by product type 5 years out from last year. So it's really 4 years out from now. The analysis on the previous page basically showed how to take each of those blue bars and figure out, how many masks are built by each type of writing tool. The green bars are the growth predictions that I came up with after looking at a lot of data from many different predictions, talking to customers, what they expect, et cetera, and then going across the different product types. And you can see there that there's some pretty robust growth in some of these areas. Don't worry that DRAM looks like 0%. All that means is there's very high leverage per mask set for DRAM. It might be, even if it's 10 or 15%, the number of sets is so low, it almost doesn't matter. Anyway, once you subject a green bar to the analysis I did, what we come up with now is what does the writing toolkit have to look like worldwide in 2022, right? So this is what it's got to look like. And what I'm showing here is mask demand by the different types of writing tools. So the horizontal axis is the writing tool type. The vertical axis is the number of masks built. And you can see advanced beams are going to go up a lot between 2017, the green part, and 2022, which is the black part. That just kind of shows that there's very robust growth. And I'm not talking just 10.7.5, I'm talking even out to 40 nanometers, 65 nanometers. And don't be dismayed by the standard mature laser bar not looking very big. Actually, on the lower right, you can see the real graph. Most masks are built on laser writing tools today. There are almost 500,000 masks a year built by laser writers. And I couldn't fit it. I mean, you can see the scale. Everything else looks like it's in the noise on the right. So I made 2 charts so you could see that scale as well as how other things are going to grow. At any rate, assuming the advanced eBeam tools are built that we can actually fulfill that gap, there's still about 100,000 standard and mature masks that need to be built in 2022 that we don't have the writing tools to build today. So now this is the writer tool base demand. Okay, so this is based on how many writers we have today, how many we need, assuming we write at the same rate on the writers we have today with the increased demand in 2022. And you can see we need a lot more high-end beams. We need a lot more standard beams, frankly, and pretty much more of everything. Today, there are around 375 mask writers in the world. It's roughly equally split between beams and lasers. And over the next 5 years, demand for all writing platforms, regardless of technology, is going to grow. That's good news, right? That's what it says. Great news, in fact. Well, not exactly. So why isn't it such great news? So this is just a snapshot of the mask making toolkit health as of today, or as of 6 months ago when I made this chart. And what I'm giving is a prognosis for 2020. What is it going to look like? And I've divided it by the different process modules in making a mask, from right all the way out to the different kinds of metrology, and going from very mature on the bottom to advanced technology on the top. And you can see that with the kind of glaring exception of inspection, we have a problem. We don't support the older tools. And these are the tools that are used to build this 200 millimeter resurgent stuff, right? I've divided this up into service and parts in each bin, and those really denote whether or not you get available service or parts from the OEMs. So, you can look at red under, PEB and develop and say, well, what do you do? Well, we maintain our own tools. That's pretty much what you have to do, right? At any rate, the demand is not consistent with the toolkit health in 2022. It's just not consistent. Only advanced tools are being built. So what do, right? The older tools are actually going to be de-supported. We've been told by multiple suppliers they intend to de-support. So how do we close that gap? So that's the next part of the talk. This will be short and hopefully not very painful. This chart shows, again, by the different mask type or writer types, it shows the number of writers required. The blue line is the number of writers actual in 2017. The forecast is the number of writers required, which is the red line for 2022. And then the what is that, gray or green line is with literally no growth, right? So no real growth in the market. What's going to happen? Even with no growth, mature retirement of eBeams, mature eBeam retirement is going to create a need for mid-range beams and advanced laser tools. So it's interesting that even if we have no market growth, we're going to be retiring tools and we have to replace those because basically we're full today, right? So how are we going to do that? But if you believe my forecast, we need 100 advanced eBeams over 5 years. That sounds like a lot. Well, we have 80 some in production now, so it's not that many. We need about 45 mid-range beams, 10 or more advanced lasers, which are deep UV laser tools, and then around 20 standard and mature laser tools. And that is, that's a lot of tools. So this is a prescription for how we extend, how we make mask tool lifetimes extending. The first is we have to modernize the toolkit. That means we need to narrow the number of supported platforms. And let me give you an example in metrology. If I have 5 generations of CD metrology tool, I can't expect a metrology tool supplier to support every platform forever. So pick one legacy platform and one modern platform and sustain those and give me 20 years. That's all I ask. 20 years sounds like a lot. I have Core 5, and I think it's about 32 or so at this point. It's pretty old, but it still runs. My oldest Alta is almost 24 years old, runs 24/7. So, you know, I need 20 more years out of those tools. And we can do it. We know we can do it. We're already doing it. The second is to take existing tools that you're going to support, modernize those tools. So give me an upgrade path that I can modernize my tools. And then the third is, once we've done that, then gradually retire unsupportable tools and replace them with a modernized platform. All right, so let me give you the example of low-end eBeam riders. In a near-term horizon, i.e. 2-3 years, redesign the laser and mid-range eBeam rider data paths. Just as an example, I'm taking data path because data paths were horrendously complicated 20 years ago, and now, you know, I feel like I should hook an I/O board to an iPhone and run it, you know? I mean, I know it's not that simple, but it's a lot simpler now because we have very high-speed generic computing platforms available. So modernize the data path. Make it scalable and generic. Then provide that package as an upgrade to existing mid-range eBeam tools or advanced laser tools. I'll buy the upgrades if you provide them, okay? Then that allows you later on in a longer time horizon, 5 years, 7 years, whatever it is, to retire the low-end beams over some amount of time. We can segue from those, and then you'll be able to fill that gap that's created with a more modern platform of mid-range eBeams and advanced laser tools. Make sense? I mean, it makes sense to me. So just to give you an idea of what that might look like, and this is for legacy eBeams, so older eBeam tools. So let's say that we're going to retire 2/3 of the mature eBeam tools in the next 5 years. And we move the retired tools work to other tools. And let's suppose that we can move 75% of it up to mid-range beams and 25% down to deep UV laser tools. And you can see there I've made some assumptions about the speed. Mid-range beams are faster than legacy beams. And of course, advanced lasers are faster as well. So whether the market growth is, as I predicted earlier, or zero, it doesn't matter. We still are going to need mid-range beams and advanced lasers to take that stuff, to take that work, because the work's not going to go away. So then, of course, the predicted output is additional demand by, you know, different platforms. And you can see here, I've just shown 6 mature eBeams, which becomes basically 2 that handle still about 33% of that work. I throw out 4 of them. Half the work goes to 2 mid-range beams, and then about 1/6 of the work goes to half of an advanced laser tool. So give or take, that's kind of the simple math, right? So that all sounds great, right? I want to buy your tools. Now for the really tough news. What I'm showing here is, and I've normalized it because I can't really talk, you know, actual pricing. It's kind of against the law to do that. But what I'm showing on the blue line, which is this nice sort of asymptotic decrease, is on the left axis. And that's a normalized price of a 65 nanometer logic mask set over time. Okay, so in 2005, it was 1. That was the most we ever got for a 65 nanometer mask set because that's when they were introduced. And today, it's about 8% of that. So you can do the math yourself, whether it was $1, now it's 8 cents. So what I paid for an eBeam to build, you know, the most advanced mask in that set 13 years ago, I can't do it today. I can't buy that beam for that price. So the tool manufacturers have to come up with a way to actually reduce the cost of manufacturing their tools as well, right? It's not so simple as just saying, I'm going to sell more beams. The beams have to be built more cost effectively, and they have to last for a much longer time now. We have to agree they're going to last another 20 or 25 years. The red and the green are really, they're over on this axis, and notice it only goes to 0.2 because this is sort of a, the red is actually the depreciation cost, and I've given it a 7-year straight line depreciation, so which might hit every year to P&L, and it's around, what, 15% or so, right? And then it goes to 0, but the maintenance cost, which is green, actually starts after a year because I get a warranty, and then it kind of stays at around 5–6%, but it starts to increase as the tool gets older because it's harder to maintain, right? So it's nice these numbers go down, but this guy goes down as well. So the problem is the original asking price for the tool, this stuff right here, I can't pay that now. So we need a different strategy for how to support these things. And you know, the case study again, 65 nanometer logic, that you know, more than 50% of the masks are built with beams that have to be modernized or replaced, and the mask set price has dropped 90% in 13 years. So today's business model just isn't going to you know, be supporting 2005 eBeam pricing. But let me give you a summary of the riders, because that's just beams, but I want to talk about all the different riders. So the advanced beams, it's a healthy market, right? About 20 tools a year over the next 5 years, that's great. We have 2 viable suppliers, and their total capacity combined will match that 100 tools over 5 years. So I feel like that's okay. I think we're all right on advanced beams. Standard and mature beams I just talked about. So renew the standard, retire and replace the mature, the standard market's going to expand. That's good business for somebody or somebody's, right? Maybe even more than one company. Advanced laser riders, the market is healthy. It's actually stayed pretty healthy over the years. Not huge, but healthy. The manufacturing infrastructure is okay. They have a modernization strategy. The capacity can meet the demand. For standard and mature lasers, it's similar to standard and mature beam. We need to pay close attention to this sector as well. These 2 sectors are at risk. We need to renew the standard and retire and replace the mature, and the standard market will expand as a result. Market's exploding. We have about a 70 tool gap in low to mid-range manufacturing capacity over the next, I say 5 years, maybe it's 10, but as we retire the legacy tools. But we can close that gap if we act proactively by retiring mature platforms, but replacing them by modernized select platforms that exist today. And we can expand that to the entire toolkit. This isn't, you know, riders are just another tool. We can do the same with inspection tools, repair tools, whatever. So, you know, my assertion is we should extend this thinking to the entire mask toolkit. And that's it. Thank you very much.